Hi everyone. Today we're going to start a new lesson on transformations of functions, but before we can start transforming functions, we need to learn about all of the different functions that we have and that we can transform. And these are called special functions. They're what's special about them is that obviously they can transform and they take on specific shapes based on what the equation looks like. So in order to do well with this self-check, you'll need to have the Unit 4 key terms in front of you, whether it's on a different tab or printed out, it doesn't really matter. But that key term sheet will give you all of the different special functions that we have at our disposal. And we're not going to talk about all of them, but we are going to talk about the majority of them. That's why I made this and had all of them printed out, or had them all on that key terms page. So for this specific self-check, we're just asking about what the parent function is. Now the parent function is basically like the basic function. If I were to just graph the basic function, it would look similar to the transform function. Maybe it would just move over a little bit, or be skinnier, or be fatter, turn upside down, something like that. The same thing goes for the equations. The equations will look really similar to each other. It just might be like have extra numbers somewhere. So let's just get started with the first example. All of these are asking you for what the parent function is. So the first example says f of x is equal to x minus 3 squared. The first thing I notice is that it has a squared on there. So what I'm going to do is I'm going to look through that parent function sheet and see which ones have squareds on them. Now, two of them have squareds. One of them is just y is equal to x squared, and then one of them is y is equal to 1 over x squared. But in this case, because there's not a fraction involved, I know my parent function has to be that y is equal to x squared. So this is my answer for this guy. That's like my basic function, and then this equation right here is the one that's transforming it. And then in videos after this, we'll learn what it's transforming it to, what it's doing, where it's moving it. Okay, so for the second example, we have f of x is equal to 1 over x plus 1. So now I'm really looking for a fraction with an x on the bottom. And once again, we have two versions of that. We have a 1 over x, and then we have a 1 over x squared. Because in this case, you don't have a squared on the bottom as well, then my parent function would just be y is equal to 1 over x. And once again, this parent function is the most basic version of it, and then the thing that it's talking about right here, the actual question that it's giving me, is the transformed version of that. Okay, so now let's take a look at some graphs. On the graphs, once again, you're going to be looking at that key term sheet, and they give you what the parent function graph looks like. So we're looking for something that looks like this. For example, number 3, kind of a curve off to the right, and it stops at when y is equal to 0, or it has a stopping point. When I look through all of those graphs, there's two that look similar to that. One that's y is equal to the square root of x, and then the other is y is equal to log of x. I'm going to tell you it's not the log of x one. The log of x one just continues to move down, where the square root of x actually stops. That's what we want, is where it just stops. So my parent function in this case is y is equal to the square root of x. And that graph would look like something like this, where instead of starting down below, it starts right at 0 and then just moves up. All right, and then this last example has a bunch of steps. It's actually called the step function, or an integer function. And so if you look down at the very bottom left-hand corner of your key term sheet, it looks exactly like that graph. It's going to be y is equal to the integer of x, or I'm going to just use those brackets. This is the other way we can write it, and that's the way that we're going to write it for the remaining videos and self-checks. So this is my parent function. It's called the step function for this graph. All right, and this is how we discover parent functions for special functions.